Hello everyone, I'm Seong-Yu Kim in the School of Management Engineering at UNIST. Linear algebra and probability statistics and optimization are the mathematical pillars of machine learning and deep learning. The goal of machine learning and deep learning is to construct a function that classifies the training data correctly so it can generalize to unseen test data. For example, license plate recognition system. The system has to learn how to recognize numbers 0, 1, 2, 3, up to 9, and some characters on the license plate. To make the problem to be a little bit more difficult, we may think of a system that has to recognize handwritten digit or characters. Anyway, as you see, the essence of machine learning and deep learning is to learn from data, and it involves a learning function. Let's talk about a learning function f. The input to the function f are vectors, matrices, or sometimes tensors. For example, in the problem of identifying handwritten digit, each input sample will be an image, which is a matrix of pixels. We aim to classify each of those images as a number from 0 to 9. Those 10 numbers are possible output from the learning function. In this example, the function f learns what to look for in classifying the images. The inputs are the samples v, the outputs are the computed classification w, which is function of v. The simplest learning function would be linear, which is w equal to a times v, or av. The entries in the matrix A are the weight to be learned. This is not too difficult. Frequently, the function also learns a bias vector b, so that function f of v equal to av plus b. This function is called affine. Affine functions can be quickly learned as well. However, in many real problems, linearity is a very limiting requirement. Linear or affine learning functions may not be sufficient. This is why deep learning is so popular today. The functions that yield deep learning have the form of composition like this. This is a composition of affine functions LV, which is AV plus B, with the nonlinear functions R, which act on each component of the vector LV. The matrices A and the bias vectors B are the weight in the learning function f. A's and B's must be learned from the training data so that the output f of v will be nearly correct. Finding A's and B's from the training data is called parameter estimation in statistics. We can find them by solving optimization problem using well-known techniques like gradient descent algorithm. Then f can be applied to new samples from the sample population. As you already noticed from the previous description, to understand the deep learning, you need a background in probability statistics, optimization, and linear algebra altogether. Among them, linear algebra is crucial because you can learn mathematical notation and arithmetic, matrix factorization method, problem-solving techniques. You may be not familiar with some notations and terminology in the previous description, such as vector, matrix, tensor, linear function, affine function. Actually, that is why you need to learn linear algebra. In the next video clip, we'll talk about linear algebra notation and arithmetic briefly. For someone who wants to study linear algebra more deeply, I'd like to introduce a linear algebra open course at MIT by Professor Strang. Thank you.